In our last video, we talked about covalent and we talked about ionic bonds and the differences between them. And there's some pretty significant difference, right? So covalent bonds, co means with or together. And in that scenario, the atoms are actually going to share their electrons. So they're going to have very similar electronegativities, which means that their pull on electrons is going to be similar. So let's say one has 6 electrons in the outer ring and the other one has 2. That's probably going to be closer to maybe an ionic bond. It could be covalent depending on the situation. But let's say it's like 4 and 4. If one atom has 4, the other one has 4, we know that they don't want to give up any electrons, so they're going to share. So that's going to be called a covalent bond. Now, one thing I did not talk about in that short video lecture was something called polar versus nonpolar covalent bonds. So that's what we're going to talk about today. Polar, when you think of the poles, right? Let's think about when you hear that word. What does that mean? So if I were to draw something you're probably all familiar with, which is the Earth, right? So if I draw the Earth here, so let's say this is the Earth and, whatever, we got our continents. We're not going to worry about my artwork right now, but let's say these are some continents here. All right, so we got our planet, we got our Earth. The pole goes right down the middle, right? If I say, where's the North Pole, where's the South Pole? The North Pole is here, and the South Pole is down here, right? Can they get any farther from each other? The answer to that question is no, right? So polar in this case means far apart. So the more polar it is, the farther apart they are. And that term is going to be used in this scenario, and that's pretty much what it means. So let's go back to those notes real quick. In a polar bond, let me move my video here out of the way. So this is going to occur when those bonds share their electrons, but they're not shared equally. What ends up happening is you get a slight negative charge on one side and a slight positive charge on the other. So what the heck does that mean, right? Well, let's talk about that for a second. Imagine tug of war. Imagine if I was playing tug of war. And, I'm not the biggest guy, but let's say I was playing tug of war with somebody that was my exact same size, and we were just both pulling. What would happen is we would not get anywhere, right? We're both pulling with the same amount of strength, so that we're not gonna, it's like nothing's happening, right? But let's say one of us is a little stronger than the other one. What's gonna happen there is we might still be holding the rope, but one person's gonna be pulling a little more, so it's gonna be more towards their side. Well, that's exactly what happens with a polar bond. So let's go over an example. The best example that I can think of a polar covalent bond would be a water molecule. Water molecules are extremely polar. So let's talk about water for a second. Water is made up of 3 elements, right? So you got, let me try this out. We have our oxygen molecule, right? H2O, right? And then 2 hydrogens attached to it. So a lot of times you're going to see water molecules drawn something like this, where you have your oxygen and your 2 hydrogens. And what ends up happening here is because this is a covalent bond, so they're sharing their electrons, but it's an imbalanced charge. So I want to talk about why. So let's do oxygen first. Oxygen has 8 electrons in it. It's got an atomic number of 8 and it's uncharged. So in its first ring, it's going to have 2. Right, we have 1, 2. And its second ring, it's going to have 6. 1, 2, 3, 4, 5, and 6, right? So we got 6 here. This is unhappy because it's missing 2, right? It needs 2 electrons to be happy. Well, luckily, hydrogen comes along, right? Now, hydrogen has 1 electron in its outer ring. So we're just going to put O here for oxygen. And hydrogen has 1 electron in its outer ring. So we'll draw our outer ring here. It's got 1 electron. And then we'll have another hydrogen over here, which also has 1 electron. Now the thing about, and these are also both unhappy because they want to have 2, because their inner ring can hold 2, and they're missing 1. So I guess you guys are obviously able to see this, but what can happen here is we can have everybody happy if we form a covalent bond here, where this electron gets shared and this electron gets shared. So now we have a scenario where all 3 of these atoms are going to be stable, because when they share their electrons, they end up with 8 in this one and then 2 for both of these. But one thing I want you to notice over here is, I'm going to circle this with a blue, all of the electrons on the oxygen are kind of over on this side, right? And if you take a look here, there aren't any over here. So what that does is it makes a scenario where there's more negatives over here there's less negatives over here. So what you end up with is essentially a magnet. So this forms essentially a tiny little magnet where there's more negatives over here and more positives over here. So you're going to have a slight negative charge on this side and a slight positive charge on this side. So this is a polar bond because there's a difference in charge from one side to the other. It's not a charged particle. It is not an ion, but because one side's got a stronger pull, this oxygen's, it's like playing tug of war. This oxygen is just stronger than the hydrogen, so it's going to pull the electrons that direction. A nonpolar bond is the exact opposite. A nonpolar bond is going to have an equally shared electrons. So it's going to look like an example of that would be oxygen gas. Hydrogen gas is a great example of that. Let me move my video up here. Hydrogen gas is an example of that. So they share their electrons equally, and there's a scenario where neither side is more positive or negative than the other, and it doesn't attract to anything. So like, for example, oil is made up of nonpolar bonds. If you put oil in water, the oil doesn't attract to the water. And then the last type of bond that we have to talk about, we already talked about ionic bonds. The last type of bond we have to talk about is called a hydrogen bond. And all you need to know about hydrogen bonds for now is that they are when hydrogen forms with another atom. So hydrogen has a slight positive charge, and it's going to attract to another bond, usually another hydrogen, or in the case, it's usually going to be in water. This is what forms bonds in water. It's what makes one water molecule attracted to another water molecule. So they bond between hydrogen and another atom because of the high polarity. It holds water molecules together, and it's an extremely weak bond. That is why it's easy to boil water. If you heat it up to 100 degrees, it'll boil. Those elements will start to move around and shake. So if you take a look here, you can see in this image, we have I just went over that idea of polarity, right? We have a slight negative charge on this side, a slight positive charge on this side, a slight negative charge, and a slight positive charge. These are not ions. They are not charged. They just have a slight charge because of the imbalance of electrons. So what that means is when this slightly positive side gets in contact with this slightly negative side, they're going to attract to each other, and they're going to form what's called a hydrogen bond. This is an extremely weak bond. So if I put the bonds in order from strongest to weakest, the strongest is going to be a covalent bond. Those electrons are being shared. They're being held together like glue. That is not going to break easily. So covalent bonds are very strong. We are made of covalent bonds for the most part. All of the parts of our fats, our proteins, our carbohydrates, these are all going to be made with covalent bonds, and that's why they hold together. Ionic bonds are the next type, and they're going to be a little bit weaker because they have a charge. So you might have a sodium with a positive charge and a chlorine with a negative charge. So when they get near each other, they're going to attract. It's not as strong as a covalent bond, but it's still stronger than a hydrogen bond, which is the last type of bond. And hydrogen bonds are what we call a weak bond. And that is because they are really just held together by that slight charge. Okay.